Hello again, I'm Mr. Gubino here. We're going to go over the Unit 6. If you look here, the Unit 6 integration and accumulation change. Uh, they did this on the video. I'm just going to go over it a little bit, hopefully quicker. So let's get started. So we're talking about extreme values. We have a graph of h of x shown on the interval from -4 to 4. Let me put it right there. The function has x-intercepts on the interval at -3.8, right there, -1, 0, and 3.4. H of x also has horizontal tangents. Oh, horizontal. We know what horizontal tangents are. They're tangents where the derivative is 0. Oh, derivative is 0, okay? So the areas of the regions bound by the x-axis, because we're going to get into that here in just a second. Between the intervals, we have 3.4 to 4 has a area of 2. 0 to 3.4 has an area of 12, and -1 to 0 has a area. So this little teeny tiny area is 0.3. This is 12. And if we go down to 4, this is 2. For all x values, g of x is equal to 11 plus the integral from 0 to x of h of t dt. Now remember, when we're looking at this, this is the second fundamental theorem of calculus, and this talks about, we talked about how it goes from 0 to x, some value, and this is basically a dummy value, a variable, dummy variable that you don't necessarily need. You can call it whatever you want. Don't call it x. But those will help you find the area. So again, this is looking for an area under a curve. All right, g of 3.4. So I'm going to go way over here. G of 3.4. What you are going to do, let me see if I can zoom in on that. No, I cannot. Okay. Just plug in. So that's going to be 11 plus, we got the area between 0 and 3.4 of h of t dt. And the area between 0 and 3.4 is this 12. And because we are moving this way, anything that is below is negative. Anything that is above is a positive area. All right, so this would be -12, which would give you a value of -1. So this is -1. G of 4, same thing. G of 4 is 11 plus 0 to 4 of h of t dt, and that's going to be 11 plus. So if I'm going from here to here, I got a -12, and I got a +2 because now I'm adding this little area, which is going to give me +1. So g of 4 is +1. G of -1. G of -1 is going to be the 11 plus 0 to -1 of h of t dt, and that is going to be 11 plus, but if I go this way, now let's just be aware that if we go this way, which we are doing because we're going from 0 to -1, that anything below turns to positive, anything above turns to negative. So this is minus 0.3, which is 10.7. So g of -1 is 10.7. All right, moving into this, we have now the derivative of g. That's not the derivative. So what we're going to go up here and do is we're going to take the derivative of both sides. All right, so let's take the derivative. Let's use a little green pen. So we're going to take the derivative in terms of x. Okay, so this will be g prime of x. Derivative of 11 is 0. derivative of this is going to be h of x. Because if I go from 0, so this will give me basically kind of not canceling, but they're going to knock each other out. So the slope is going to be the value. So in this case, if I'm looking for g prime of 3.4, I'm looking for h of 3.4. Well, we know that this is h, and we know that the value of h at 3.4 is 0. Alright, so we need the second derivative of x, of g. Well, that's going to be the first derivative of h. So if we need the second derivative of 2.2, we need the first derivative of 2.2. And if we look at 2.2, and that's h, what is the slope? Reminder, this is slope. What is the slope at 2.2? That's also 0. Alright, so you can pause it there, go back through. So here I am again. So we're going to go on to part B. So let's transition over to part B. It says find the maximum and minimum value of g. Oh, we need this. What's the maximum minimum value of g? So what we need to do is do some values. We need the extremes. We need this point and this point, which is the -4 to the 4. We need any of the intercepts. Oh, I'm sorry. Watch this. Sorry. That's not -4. That's -1. So we don't have to include this one. We include 0 and we include 3.4. And why we include those are the critical points. We don't include 2.2. That's not going to give us because we don't have an area. Reminder, this is an area of that curve. G of -1. Oh, we know G of -1 is 10.7. We know G of 3.4. That's -1. G of 4, +1. G of 0 is 11 plus 0 to 0 of h of t dt. And when you see this, reminder, whatever I have for h, and I'm going from 0 to 0, if I go 0 to 0, that has a rectangle with no height. So this will be 0. So this value would be 11. So g of 0 is 11. So that could be given up here someplace in the directions. But usually we can find it two places, off of that function or off of that one. So the max occurs at, I'm not going to do my Cardi B max, occurs at 0. And the min occurs at, where's the lowest point? X equals 3.4. Okay. Explain your answers. Basically, explaining your answers would be showing all of this work up here. Alright, I'm at the 9-minute mark. I need to get moving. Little is known about approximating areas with Riemann sums. So here we have a table. Velocities. Okay, so what we're doing is we're going to use a Riemann sum over 4 subintervals. So we need to check to see if those two, so that's that value and that value, so the -2 to 10, perfect. We need some delta t's here. So delta t between these two is 3, delta t is 5, delta t is 1, delta 3 is t. So we're going to have a 3 plus a 5 plus a 1 plus a 3. Now, left and right are going to be the same. So I'm just going to recopy these down. They're going to be the same with the values that go along with the velocities. So in purple, if we're using the left, we're using the left one. So I'm going to use these. Okay, so 9 plus 20 plus a negative 9 plus 6, and that is equal to 26. Over here in green, when we do the right, we're going to go to the right one, to the right, to the left, to the left. No, never mind. I don't know what it is about today. So we have 12 plus negative 45 plus 2 plus 0 is negative 31. All right, so trapezoid. With this, basically the trapezoid is the average of left plus right, left and right. So this would be 26 plus negative 31 divided by 2, which is negative 5 halves. Now, trapezoid otherwise would be this. 1 half of delta t, which is 3, and then you take the two endpoints, 3 plus 4. And you're going to continue that on, and eventually you do get negative 5 halves. So it's not that we didn't get it, there's a shortcut to that. You can take the left and right averages. So that average is 5.5. Well, I'll just set this up. Might as well. I'm right here. Plus 1 half of 1, and then I take negative 9 to 2. And then I take 1 half of 3 and go from 2 plus 0. Okay, so this would be 7/21 halves plus negative 25 halves. I'm just going to keep them as halves. That's negative 7 halves, and this is 6 halves. So if you notice, those will add up to be, and you can do that with your calculator, the negative 5 halves. All right, we're back, and we're going to go over example 3, 4, and 5. Now, 3, 4, and 5 are kind of, they've done these before, but I'm just going to do a couple of them as we go. So let's go to scene 2, transition. So the fundamental theorem of calculus states that if you have an integral from a to b of f of t dt, or f of x dt, that is going to be big F of b. So it's the antiderivative of those, and we get those values. So in this case, this right here, that's one of those common ones that maybe you should know, and maybe you should commit to memory, but that would be the derivative of 1 over x. And this is x to the 1 half power, and the derivative of that is 1 over 2 root x, or 1 over 2 square root of x. So always, that one never changes. And I talked about that earlier, that if that's like x plus 1 or x minus 4, it's still going to be this. So whatever that is. So this is going to be the square root. And we're going to go from 9 to 4, so it's the square root of 9 minus the square root of 4, which is 3 minus 2, which is uno. There's your Spanish for the day. All right. Second fundamental theorem of calculus for this one. Reminder, the derivative of this is going to kind of knock this out. So it would give me this, but if I go from x cubed, then what I have to do is put in x cubed any place that I see that t. X cubed minus 5. And then I need to take the antiderivative of this, or the derivative, excuse me. So 3x squared. So this is going to be 3x squared over, don't forget to distribute those, x to the 6 plus x cubed minus 5. So if I take the antiderivative of, or excuse me, the derivative of this, it's going to give me this. Okay? You can do that on your free time if you'd like. Go for it. All right. Definite integrals. we have a couple of rectangles here. So 5 to 6. So what we're going to do for 5 to 6 is we're going to look at taking the integral from 5 to 6 of f of x. Alright, sorry, my wife came down and gave me some motivation. So here we go. We're going to go into this. So this is, we're going to look at 3 to 6. And that's going to be the integral from 3 to 5, because we are given that one, plus 5 to 6. That's the one that we're going to find. So we're given this one. And some people write it out. Yeah. Okay, so this is 7.5. This is the flip of this. Now remember, if I go from 5 to 3 and I go backwards, it's negative. If I go forward, it's, so if that's the opposite, this should be the opposite here. So if I flip this and go from 3 to 5 of f of x dx, then that's going to be the opposite, negative 2. And then we're going to go from the negative 5 to 6 of f of x dx. So this value, if I add 2 to both sides, that's going to give me 9.5. Alright, 3 to 6 of g of x. 3 to 6, I have 6 to 3. So that's just going to be the opposite of that. That's not a simple one, but it's just the opposite of it. That's going to be 12. And then this one, you are going to kind of separate these. So you're going to go, let me do it in a different color. Let's go blue. So 3 to 6 of 4f of x dx minus, we're still going to take the 3 to 6 of 2gx dx, and then we're going to go 3 to 6 of 4 dx. So do we have 3 to 6 of f of x dx? We do. Now this 4 can come out front, so 4 times this 7.5. Alright, so we need 4 of them. We're going to subtract 2 out, and we got to go 3 to 6 of g of x. 3 of 6 of g of x was 12. And then this one, because it is a constant, it's going to be the distance between those, which is 3, and then times by 4. So basically what happens is you get this 4 from 3 to 6. So you get a height of 4, which is an area of 12. So 12 plus a negative 24. Yes, I'm working backwards. That's 30 minus 24 is 6 plus 12 is, I hope I'm right, 18. Okay. All right. Integration of sine theta d theta. So what function has a derivative of sine theta? Well, that's going to be negative cosine of theta plus c. Don't forget your plus c. Plus c. These three need plus c's. All right, this one you're going to separate. It is a separation. There are videos that I put up. You can keep that as a plus, and then 1 plus x squared. Because what you're looking for is you're looking for, name my dx. You're looking for this. This is arctan. Arctan of x. Nope, not the negative on that one. Only the negative if you have this one. So on that circuit with these types of integrations, there are several that are going to be a little bit more difficult to look at. So I'm going to do those. I'll do probably 4 of them at some point. This one you want to look at 2 minus g to the negative 2/3 power dg. You can find it that way. You got to use chain rule in there. Okay, so just make sure. Now what the teacher's virgin Mark said on the video is that you can take the you're going to need the antiderivative of this, or the derivative, which is -1. And so in order to cancel that out, you're going to bring out a -1 anyways. Or, excuse me, you're going to bring that out, have that already. Okay. This is from one of those units that we did back with integration. We don't have this because we don't have anything that goes along with u sub. We don't have a 2x. So we're just going to have to look at it as an area between those, because this is finding area. All right, so that should lead you into the notes for that. I'm going to post the videos that go along with the antiderivation, and we'll go from there. Have a good day.